Okay, so question 10 asks, how do you calculate the enthalpy change of combustion? Okay, so let me write out the definition of enthalpy change of combustion. And its symbol the delta symbol stands for change. So delta H is enthalpy. Then I'll just put combustion down there. So enthalpy change of combustion is the heat, energy, given out when 1 mole of a substance burns completely in oxygen. Okay, so let's have an example. So let's say we had a hydrocarbon propane plus oxygen the products of every combustion reaction is CO2 and water. Just write states. Okay, so now let's balance this equation. There are 3 carbons on the reactant side, so we need 3 carbons on the products. There are 8 hydrogens on the reactant side, so I need to put a 4 in front of the water, since H2O contains 2 atoms of hydrogen. So now on our product side, there are 6 plus 4, so this gives us 10 oxygens in total. So I just need to write a coefficient of 5 in front of the oxygen. Okay, so usually in a question that asks for the enthalpy change of combustion for the whole reaction, they give us the delta H of formation for all of the reactants and the products that are involved in the reaction. So I'm going to write down all their values at the bottom. So for the propane, it has a delta H of formation of negative 105 kilojoules per mole. So pure oxygen gas has a delta H of formation of 0. Carbon dioxide, its value is negative 394 kilojoules per mole. And in the case of water, it is negative 286 kilojoules per mole. Okay, so to answer this question, I'm going to write the general expression to find the enthalpy change of combustion for this reaction. So generally speaking, this is equal to the sum of the delta H of formation of the products So notice that I put N, which stands for number of moles. So this depends on how many moles there are of each substance. So the sum of the enthalpy change of formation of the products minus the sum of the enthalpy change of formation of all of the reactants. Okay, so I'm going to write down all the values so that we can see what this would look like if we were to plug in all of our values. So first, for our products, it's going to be 3 moles. So first, let's look at the CO2. So 3 moles times negative 394 kilojoules per mole. Next, this is going to be added to 4 moles times the negative 286 kilojoules per mole from the water. Okay, so those are all of our products. And now I'm going to minus, and I'm just going to continue the line at the bottom here. So for the propane, there's only 1 mole, and its delta H of formation value is negative 105 kilojoules per mole. And lastly, there's 5 moles of oxygen, but its delta H of formation value is 0. So we know that this will just cancel out when we do our final solving of the answer. Okay, so if you were to calculate this whole thing, the units of moles all cancel out, and we get a final value of negative 2,221 kilojoules. Okay, so let's see what our junior tutor said about this question. It may depend on the problem given, but in most cases, the enthalpy of change of combustion can be computed using Hess's law, which is the same as the enthalpy of formation. Given that you have the combustion of alcohol with the general formula CXHY, the combustion reaction is written as, and then they have our coefficients shown as well. So ACXHY plus BO2 makes CCO2 plus DH2O, where A, B, C, and D are the coefficients of each species in the reaction, which will depend on the balancing of the reaction. Okay, so this is similar to how I balanced our combustion reaction in the example. And Hess's law states that the enthalpy of reaction is the sum of all the enthalpy change present in the reaction, regardless of the number of steps it took to go to the current reaction we are paying attention to. In the equation, we have delta H of formation, or of the combustion, is equal to the sum of the delta H of formation for the products minus the sum of the delta H formation of the reactants. So it is important to know the enthalpy of formation of each species present in the reaction. Using the combustion reaction given, the calculation of enthalpy of formation or the enthalpy of change of combustion is the following. So you can see how they showed that you need to put the number of moles into account when you need to calculate for the enthalpy of formation. Okay, so they did C times delta H formation of CO2 plus D times delta H formation of H2O. All of that minus A times delta H formation of your alcohol or your hydrocarbon. Lastly, plus delta B of the delta H formation of O2. So that B should be in front of the delta sign. But nevertheless, this solution is still correct. Alright, so